Wait a second, please. Just setting up the recording. Okay. Now, so for crap. Okay, so for this one, I just want to tell you that in this question, it really all this what is written is irrelevant. So it's all right if you read it. It's not really important. You can always come back to it. But just look at the things. They say there is a card of length L, um, and the mass of the glider B is m, and it is initially at rest, and then glider travels at constant speed and blah blah blah. It doesn't really matter. So the real thing is this equation. Now, the very first question, always you'll see this, where she will say, okay, um, a graph is plotted of 1 upon v on y-axis against m on x-axis. So determine the expression of gradient in y-intercept. Now, so ideally what you want to do is that you want to you have to make 1 upon v the subject of the equation, and how to do it, basically you take the reciprocal. So if I take the reciprocal, it would be 1 upon v equals to m plus a over 2 u a, like that. Okay, I don't know what u was, I don't really know. Wait, okay, they haven't written anything already, fine. So then what you
It's written constant velocity.
okay, sorry. So then you can divide this, so it will be m over 2 ua plus a over 2 ua, a and a will cancel out. This will be then m over 2 ua plus 1 upon 2u, like that. Okay, now you need m on the x-axis, so what you're going to do is then write it as 1 upon v equals to 1 upon 2 ua times m. I can write it like this, right? Just separate it. Now you can compare this equation with y equals to mx plus c, and if you look at it, 1 upon v is y, right? M is on the x-axis, which means the gradient has to be 1 upon 2 ua, and the y-intercept has to be 1 upon 2u. So we're going to write it like this. As simple as that, right? Is it clear? So basically you just need to, change the whole thing depending on the equation and compare it. This is similar as P3 last question number 1, and then go to the next one. In this particular question, they are saying that there is m, there is time, and then there is 1 upon v. In this one, they say calculate and record the values of 1 upon v in table where 1 upon v is equal to t over L, right? And they have given L as a constant value right here, and include the absolute values as well, right? So to find this, we need to divide t and L. So what you're going to do is, first of all, we'll fill the table with the values that we need. So you take out the calculator and go along with me, and I'll tell you what to do next. So 0.23 divided by 5, that's 0.046. Then 0.26 divided by 5, that's 0.052. And then 0.31 divided by 5, that's 0.062. 0.36 divided by 5, that's 0.072. 0.40 divided by 5, that's 0.08, and then I'm going to add a 0 here just to make sure that my significant figures are same, right? Then 0.44 divided by 5, and that's 0.088, right? Once we've done it, then they say that include the absolute uncertainty. So that's what we need. So we'll write plus minus, plus minus, plus minus, plus minus, plus minus, plus minus. Now in here you just need to revise the uncertainties of AS. If you have forgotten about it, please go to my channel and check out the video, right? There are many videos there, you can actually learn from this. So for uncertainty, this is the equation. So for the uncertainty in 1 upon v, I need to do 1 upon v, take the ratio, and then uncertainty in t over t plus uncertainty in L over L, and there's no square, so that should be the equation. And this is how we're going to find the uncertainty. So what you're going to do then is that if you look at it, all the uncertainties in this one is the same. So you're going to write 0.01, and I'm going to do a very clever thing here. Okay, what I'm going to do is, in fact, no, I cannot do this. So I have to do it individually. That's 0.23 plus length is 0.1 over 5.0, and then we got to multiply this with the value of 1 upon v, right? Okay, so let me tell you exactly, like here, which is 0.046. So this will give us the change in this, right? So we need to do this. Now you take out the calculator. It will take some time, of course. So in the calculator you can just make an equation, 0.023, and if you basically use this particular format that I'm using, it will help you doing this rather quickly. So always try to follow this up, 0.046. Now in this particular thing, when you do this, uncertainties are usually, if they're usually written in one significant figure. Okay, so this will be 0.003, right? And it should be the same decimal place as the actual value that written. Okay, so make sure that you follow that rule. Now for the next one, what I'm going to do is I'm going to change this value. I'm going to write 0.26 here, and I'm going to change this value because this changes. I'm not changing anything else in the calculator, so that will make it faster. So this is going to be 0.003, right? And then the next one, I'm going to change this as 3.1 because the rest of the things are like the same in every equation. That's why. So be smart here. 6.2. So this is going to be 0.003 again, and then the next one, I got to change this as 7.2 and this as 3.6, I believe 3.6. So this is going to be 0.003 again. Sometimes he also allows like uncertainty written in more than one significant figure if there's no difference, but sometimes he doesn't, so it's all right. Then it's this one is 0.40 and this one is 0.80, so you got 0.004 now because you round it up, and then you gotta take this as 0.88 and this one as 0.44 and this is also 0.004, just like this, right? Now, so when you're done with this, that's basically all that you need for this table, but I just want to bring your attention to another very important fact. The important thing is sometimes, they will give you, like, suppose they say t and then they take, okay, you need to find, I'm just supposing this, okay, so in another question they were like, find ln t and then the absolute uncertainty as well. So ln t is like you take ln of the value, like you could have taken ln of 0.23 and you got a value and so on. But the thing is that how do we find the uncertainty of logs? So I'm just putting a point, note please. So for logs, what you're going to do is you are going to take log of the value like t plus delta t minus the log of just t. So this will give you basically the uncertainty like this. So if this is for ln, so ln and ln like this, or log. So you need to remember, and how do you do this? Like for example in this one you could have done ln 0.24 and this would be ln 0.23. Is it clear everybody? So basically in case a log question comes, so you have to take the highest possible value in the uncertainty, a log minus the lowest possible value. I mean the middle value, that's the mean value. Is it clear? Any questions?
So can you repeat that please?
What I'm saying is, you also do a question. Let's suppose they're like saying, this is not the part of this question, but it could be any other question. Let's say, okay, find ln t and the uncertainty. Okay, so they've given you this. So what you're gonna do is you're gonna take, like for the first value you say, okay, ln 0.23 and then this is the value. Okay, you write minus 1.469. Well, this is not going to have whatever. The thing is that if you want to find the uncertainty of the log, what you're going to do is you're going to take the log of the value that is the highest in the uncertainty. How do you find this? You basically add this value with this value, so it will be 0.24, right? 0.024, yeah. And then minus with the mean values log, like 0.023. Suman, do you understand this?
Yes, sir.
So what do we mean by log and ln?
ln is basically a function of the log, all right. Basically there are two functions. There's certain like log could be to the base power 10, but well, you don't take maths, right? You haven't taken maths?
I don't.
Taken maths?
No.
Oh, okay. Okay, so in your calculator, just let me tell you, logs have two different functions, ln and log log, right? It's just a function. You don't need to know what exactly it does. You just need to know that, okay, log itself is like when you put in a value, it gives you a value, but that's entirely with the math thing. You don't need to worry about it. You just need to, like for example, if they say you want to take log of say value of this m, right? Log of m. So log of m would be that the value is 271, so you press log and you write 271 and then it is going to give you a value. Do you understand?
Yes, sir.
So it's just a function here. You don't need to go into detail of what log is. That would be the math part. But the thing is that in case a log function comes, you need to remember that to find the uncertainty, you will take the highest value of the uncertainty, and like you add it up and then take the log and subtract it from the log of its mean value. That would give you the uncertainty in it, right? Any questions? All right, when you go to like when you cover few more topics, right? When you do a lot of papers here, you'll find it, and inshallah, then we'll see it what basically happens. So you don't have to worry about it. Anyway, then goes this part where it will say plot a graph against 1 upon v and mg and include error bars. We're going to come on to error bars. So for the first thing we're going to do is you're going to plot these points, right? So the graph is already like the axes are made, everything is made, not like paper 3, so you have ability to just focus on the plotting. So first of all, we're plotting 0.046 against m, right? So the first value is 0.046 and 271. So we're going to go to 271. So this is 250, 250, 260, 270, 280, 290, 300, 270, and this would be like very close to this, and we got to go 0.046. So we're going to go up and 0.046. So here it will be 0.046, 47, 48, 49 and 50. So 0.046 is this point. So what I'm going to do is I'm going to put a small dot here. Now I just want to tell you the rules for plotting. So for plotting, remember, number one, no blobs. Blobs mean that basically when you zoom it in, this is the one box, right? So basically your dot should not be bigger than one half of the box, which means if you basically make a bigger dot like this is called a blob, and it would be a big one like this. You don't have to do it, just make a small dot. You can just make a circle around it just to identify that, okay, I've plotted a point here, nothing other than that. Now then what you're going to do is the next value is 0.052 and 369, 0.052. So this is 350, 360, that's 370, so 370, and then 0.052 is going to be 51 and 52 right here. So I'm going to make a dot here. You can also make crosses, it's fine, but make sure that that's a light cross, small one. And then the next one is 490 and 0.31. 490, 0.31. 490 would be 60, 70, 80, 90. 490 and 0.31. What? That's not fair. Oh, 0.062, sorry. 0.062. So that's gonna be 0.61 and 0.62. So this would be your dot again. Then the next one is 632 and 0.072. 632. So 6, 10, 20, 30. 32 would be a bit, right, but it's fine. 632 and 0.072. So you go up the middle and next to this. Okay, 72, 630, 0.71 and 2. Okay, so this would be the point. Mark it like this. And then 741 and 0.080. So 741, this is 40, and then 0.80. 740, 0.80. So it is going to be right here, I believe, right? And then going to 840 and 0.88. 840 is going to be this one, and 0.88. 88. So this will be 885 is here, so 86, 87, 88 right here. I think I missed it. It should be here. Let me see. Yeah, 840. Yeah, that's fine. So now that we have plotted the whole thing, now we're gonna make the error bars. So how do you make the error bars? First of all, I would like to tell you that the value that has uncertainty is 1 upon v. So which means that error bars are would be vertical. If the value with the uncertainty was horizontal, then error bars would be horizontal. Let me show you how to make them. So for the very first one, we have to make an error bar of 0.003. Okay, so and plus minus means above and below. So let's check this out. So 0.003 is what we need. We're gonna check how to basically make that. What is the value of just one box, right? To check that, what you're gonna do is you're gonna take out the calculator. You're gonna write 0.045 minus 0.040. This is 0.05, and then you're gonna divide this by, okay, divide the answer by 10 boxes. So this is going, each box is basically 0.005. Okay, so for how many boxes would be required for 0.003? So 0.003 divided by 0.0005, it means 6 boxes above and below. So what I'm going to do is I'm going to make 1, 2, 3, 4, 5 and 6, put a dash here, and 1, 2, 3, 4, 5 and 6, put a dash here. Do you guys understand this? So this particular basically the bars say that 1 over v has an uncertainty of 0.003 above and below. Do you guys understand what I've done? Please let me know if you don't. Now, just the same thing with the other ones. So you got, in the next one we also 0.003, so 6 boxes up, 6 boxes down. Oh crap, wait. So 1, 2, 3, 4, 5, 6. Make sure you have a thin pencil. 1, 2, 3, 4, 5, 6. And it's done nicely. Then the next one is 0.003 as well. Sorry. Alhamdulillah. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Like this, right? And then 0.03 again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Like this. Okay. And then the last one is 0.04. So what I'm going to do is, one box is this. So how many boxes I need is, I would just switch this with 0.04. So 8 boxes now. So this will be 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. Like this. And then 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. So we got the error bars. Once you've done with the error bars, of course you get 2 marks for including uncertainty and 1 mark for plotting graph, 1 mark for error bar, and that's how we do it. Now the point is that it's like, okay, so 1 mark is for plotting. Make sure that the point is very, very small. Do not make a thick point, that is not accepted at all. And then error bars are basically very symmetrical, and don't try to make it with hand like I have done. You should use a ruler. Okay, now in the next part they will say, draw a straight line of best fit and a worst acceptable straight line on your graph. Both lines should be clearly labeled. Now what to do? The best fit line, I tell you, best fit line means equally divided points above and below. And the thing is that the other thing you should remember is, it's not necessary to include most oh crap, wait, most of the points on line, which means whether the points come on top of the line, it is not important. That's a wrong concept, that most of the points should come on the line. It's basically the division should be equal. So what you're going to do is, you're going to take your ruler. Make sure you have a ruler that is 30 centimeter and it is like a clear one, and then you try with this that the point should be pretty much equal above and below. So right now, all the points come on the line except for one point here, as you can see, which is below the line, and one point here. So that is the line of best fit, because it has equally divided the points above and below, which means one up, one down. It could have been like three up and three down. That's also fine. It doesn't matter. So you have to make sure that you don't, fall into that wrong concept. Once you've done it, just label this line as the best fit. Now, what is the worst acceptable line? So basically, the worst acceptable line is when you draw a line that starts from the highest point of the error bar and then reaches the lowest point of the error bar, like this. So this is the worst acceptable line. Now, so let me just put it here. So this line that you see is the worst acceptable line. Now, if you notice, for the worst acceptable line, there are certain rules that need to be followed. So I'm going to write it here. So for the worst acceptable line, number one, it must go from highest to lowest point of the error bars, right? So you need to remember that I picked like this line. You could also, if you wanted, you could also would have drawn a line like this. That would also be acceptable. Like this line is also acceptable, but that's up to you. Both will give you the same answer, really. But the thing is that it should go, if it's you started from the highest point here, then it should end at the lowest point. So it should be a cross like this, right? The second thing that you should always remember in the worst acceptable, that it must pass from all error bars. So if it doesn't pass from all error bars, like you see my line, it's passing from all error bars. If it doesn't pass, then it would be a wrong line. Please do not make a wrong plot. Is it clear, everybody? Any questions? Right. Now that we have done this, so we're gonna go forward, and then it says in the third part where it says determine the gradient of best fit line and include the absolute uncertainty. So what you're gonna do is basically you'll find the gradient of best fit, and then you're also going to find the gradient of worst fit, and then to find the uncertainty in the gradient, what you're going to do is you're going to subtract the gradient of best minus the gradient of worst. This is going to give you the uncertainty in the gradient, so make sure that you follow this. Now when you basically take gradient, the gradient must be shown on the graph, and it should also be like taken at least 50% away from the 2 points. Like the 2 points should be 50% away from each other. So for example, for the best fit lines, let me change the color. So suppose I'm taking this point, which seems easy. So I'm gonna make a circle, and then I'm gonna take the other point as, I think, what do I take? I think this would be easy. So I'm going to take this. So it's far enough. And then what you're going to do is you're going to make a triangle. The triangle is needed because it shows the examiner that you have taken these 2 points as the points of gradient. So make sure you draw the triangle very neatly, and then you can take these points. So this point is 250, and this was 0.41, 2, 3, 4 and 5. So this is 0.3, 4, 0.045. So this is 0.044 and 5, like this. So I'm going to take this point. So I'm going to write one of my points are 250 and 0.445, and the other point I took was basically this one, which is 0.085, and this is 810. So the other point is 810 and 0.085, like this, and you can see that right here. Okay, fine. So to find the gradient, you know the formula. It's basically y2 minus y1, x2 minus x1. So 0.085 minus 0.445 divided by 810 minus 250. So let's take out the calculator. And what you're going to do is 0.085 minus 0.4. This should be 0.0445. Probably I wrote it wrong. Let me again check. Yeah, I wrote it wrong. Sorry. It has to be a 0 here. So this would be 810 minus. When the meeting ends, you will rejoin, okay? So 250. And that's my gradient. So I'm going to write it as okay. So where was I? Yeah. Okay, you guys are still joining. I'll take it here. Okay, so what you're going to do next is basically you're going to write the gradient of best fit, which is 0.0000, and because the minimum significant for 2, so I'm just going to take it in 2 or 3. So 723 would be the best way to write it. I just written it like this. Now what you're going to do is that you're going to find the gradient of the worst fit line. So for the worst fit line, again the same method. So you're going to take 2 points on the worst fit line. I like this point, and I like, say, a very far off point, somewhere that is easier to take. Okay, I like this point. So then what you're going to do is I'm going to again draw the dotted lines just to show the examiner that basically I know I've taken these 2 points, and go down. Okay, that's very close, by the way. Okay, never mind.
Sir, does the triangle have to be so big?
Yes, the triangle has to be at least, the point should be at least 50% away from each other, 50% of the length of the line, okay?
Okay.
Now, this point is 290 and 0.045, and the other point is basically, wait a second, 820 and 820 and 0.090. So I'm going to take these points, so let me write it down here. 290, 0.045, and 820, 0.090. Okay, fine. Now I go back. It's very hard for sometimes, to do work digitally. In a page you can just flip it and look at it. It's so easy. Now anyway, so here for the worst fit line I'm going to write 0.090 minus 0.045 divided by 820 minus 290. So then it's going to be like 0.090 minus 0.045 and then divided by 820 minus 290. So this is going to be 0.0000, and I'm going to take it as 849 because I've taken the same significant figures, and that's 2, so I could take 3. Okay, so then what you're going to do is, to find the uncertainty in the gradient, you're going to subtract these values. So when I subtract this, basically minus 0.0000723, so that's going to be 0.000126. Okay, now that's my values. Now what I'm going to do is I'm going to convert uncertainty into one significant figure. That is the rule. I hope you guys have learned it in AS, 0.0001. And then I'm going to write it in standard form. So it is 1, 2, 3, 4, 5. So 1 into 10 raised to minus 5. So plus minus 1 into 10 raised to minus 5. And then I'm going to write the same thing, the same power for the other one. So this one needs to be converted 1, 2, 3, 4, 5. So 7, 7.23 times 10 raised to minus 5. Is it clear, everybody? Any
So
question?
for the uncertainty, shouldn't we do best minus worst?
Best minus worst.
I think we did worst minus worst.
It doesn't really matter because the same answer will come in minus then. Doesn't really matter, no?
Okay.
Okay, is it clear? Alright. Now, the next thing is that we got the gradient, and there's like, this is done. So now you can see that already it's like we started, well, it takes so much time, this question. Okay, so let's go forward. We passed like 35 minutes and we want to 38 minutes. We want to finish this in like 5 more minutes. Anyway, then it says determine the y-intercept of the line of best fit, include the absolute uncertainty in the answer. So basically for the y-intercept you just need to use y is equal to mx plus c, and again for the y-intercept you need to remember that you will change in y-intercept would be equal to worst or the best minus worst, or the same thing. It doesn't really matter. So let's just try to do that too. So sometimes this starts from like 0 and you can take it directly, but today it's not, so we are like, we have to use the equation. So for the best one we're going to take any point on the line on the best. So let's take this point. I think this was our best one. Yeah, this was, no, the yellow was the best one, sorry. Yeah, my bad. Okay, so I'm gonna take I want, basically this is harder scale, so I just want a fixed scale for this and the other one. So let's take this one. This is 0.070 and 600. Okay, so I'm gonna put 0.070 equals to, the gradient of the best was 7.23 times 10 raised to minus 5 times at this point was 600, so 600 right here, and then plus c. So let's do it. Oh my god, this is like a rat race, So okay, so I got the y-intercept as 0.02662 for the best one, and now I'm going to do the same for the worst one. So for the worst one, this was the ideal point I already looked at it. 0 point worst is 0 0.055 equals to the gradient of the worst. We're going to take it from the previous one, that is basically 8.49 times 10 raised to minus 5. 8.49 times 10 raised to minus 5 times the value here was 410 plus c. Okay, now let's do this. And this is going to be 0.020191. Okay, so we got this. Now we're going to subtract this, so to find change in y, this value minus the value we got, 0.02662. So that's plus minus. We're going to take it one significant figure, which is 0.006, and then for the same degree we're going to change that too. So the best one is for 3 decimal places, 1, 2, 3, 0.027. Is it clear, everybody? Any questions? Let me know. So you can, just follow this. Now, generally I would write you to write the units as well, because it's very important. We haven't written any units, so let's go back and write units. So gradient units were second centimeter per centimeter divided by mass. So this is going to be second centimeter and grams minus 1, and the y-intercept is just second per centimeter. So we have written the units as well, so make sure that you do write the units if there is a possibility to. Okay, now
Sir, uncertainty कैसी है y-intercept में?
just you have to find y-intercept of best and y-intercept of worst, and then subtract both of them, just like you did it in gradient. Okay, is it clear, Saman?
Yes, sir.
Both have the same method really. Okay, उसके बाद then it's saying using your answer to A, C3 and determine the values of U and A. Now, because U and A was basically, the gradient was this one and y-intercept was 1 upon 2u. Okay, so we're going to write again, go back. Y-intercept was 1 upon 2u, and the gradient we wrote in the very first part was 2ua, right? So first of all, we're going to find what exactly is the value of u. So what do I need? U will be equal to 1 upon 2 times y-intercept. So we also need to include the appropriate units. We don't need to include the uncertainty, thank God. So then 1 upon 2 times the y-intercept of this was 0.027. So always take the best one. Okay, 2 times 0.027, so that's going to be 18, and it has to be two significant figures, but you can take one more, so that's 18.5. And then you have you got to find A. So A would be equal to 1 upon 2u times the gradient, right? So 1 upon 2, 18.5, and then divided by the gradient value was, oh my god, 7.23 times 10 raised to minus 5. 7.23 times 10 raised to minus 5. Okay, please write it on the other side, because this was like, I didn't expect it to be this big. 1 divided by 2 times 18.5 times 7.23 times 10 raised to power minus 5. So this is going to be 374. Okay, so 3 significant here. Now for the units, because we know the y-intercept units were second centimeters, so this will be centimeters per second, and because it is an inverse of that, right? And here you have u is centimeters per second, and gradient was grams. Gradient was basically second, centimeter minus 1, and grams, right? Grams minus 1, this was the gradient, and 1 upon, and this is multiplied by centimeters per second. So seconds will go up, so it will be second times centimeter times gram over centimeter times second. So this will cancel out, this will cancel out, only grams are left, so this will be G. Is it clear, everybody? Okay, we still have okay, the time is over, but still. So determine the percentage uncertainty in A. So you got to find percentage uncertainty in A. If you look at it, the A depends on U. U has no. Okay, that's interesting now. Right, interesting. Now this is something you guys need to understand, because U was dependent on the y-intercept, and that was basically dependent on that. So we have to find the percentage uncertainty in both of them. So if I understand clearly, right, we got to find A, and A was basically 1 upon 2 UA, and please understand this is very important. So now I could write it as, because U was 2 times intercept.
Sir, A was.
Sorry?
So 2UM नहीं था?
A was 1 upon 2UM tha na? That's 2. 2UM tha, sorry. Okay. So basically I replace U with 2 over y-intercept. Okay, wait. It will be 1 upon 2 times y-intercept, and then multiplied by the gradient, right? So this is the gradient. So now our equation is going to be 2 will cancel out. This will be y-intercept over the gradient. Do you guys understand what I'm saying? Now, to find the uncertainty in A, so delta A over A will be equal to delta y-intercept over intercept plus delta gradient over gradient. So now we have to do this, and when you do this, you got to multiply this whole with 100% to find the percentage uncertainty in A. Now uncertainty in y-intercept was basically, go back, 0.006 divided by 0.027 plus in the gradient it was 1 over 7.23. 1 over 7.23, and then multiply by 100%. I didn't write 10 raised to minus 5 because it would be cancelled above and below, so it doesn't really matter if you write or not. And then just write it down like this: 0.006 divided by 0.027 plus 1 divided by 7.23, and then times 100. So this is 36.1%. Now I just want to tell you, even if your values of y-intercept and gradient are wrong, basically keep on doing the paper, because they're not going to check you for the correct values for the previous part. So there's no, basically it's an error carried forward. If you've done an error before, you can actually continue, because they only check how you have managed to find the uncertainties. And then finally they say the experiment is repeated, determine the mass m of the glider, and the car T has the value of this. Okay. Alright, so now this makes it a bit more complicated here, so let's do it. It's not a big deal. So we're going to go back to the main equation. The main equation that they gave us was right here, which was V equals to 2UA equals to M plus A. Okay, I'll try to write it as, so V equals to, okay, I forgot, damn me, wait. So this is going to be 2UA over M plus A, 2UA over M plus A, 2UA over M plus A, 2UA over M plus A. What do they need actually? They need determine the mass M. So they want you to find M, right? Okay, not a big deal. So this will be, I think, well, you multiply this will be V times M plus v times a equals to 2ua, and then you can take va there, so v times m equals to 2 times a minus va, and then you can find m.
Sir, 1 second.
Yes.
सर ऊपर वाले क्वेश्चन में a की वैल्यू आपने काउंट की थी?
नहीं, उसमें करनी नहीं है, because when you're taking a percentage uncertainty, so you're not supposed to multiply a. You just need to multiply the fraction with 100%. Do you understand?
Okay, sir.
समझ आई तुमको? Any question? Then, okay, so finally you get the equation, which is this one, and now you just need to put in the values. Okay, let's do that now. Oh, wait, let me put the charger on. It's just going to die in a second. Takes so much, effort, this question. Okay, the iPad, okay, completely refuses to charge, but that's fine. You can do that with us. Okay, now, oh, okay, done. Now, so now let's use the correct substitution. You have the value of u, so 2 times u is 18.5, a was 374 minus v. Did we have v? No way. No way, my friends. Okay, wait. Okay, yeah, we do. We can write it as, we can write it as 2ua over v minus v and v, just a, like this then, because we can divide it, then it cancels out. So 2u divided by 1 upon v, we can take the value 1 upon v was basically, what exactly was 1 upon v? Yeah, we just plotted it against the whole thing for some reason. Wait a second. But there is something, there is something that is missing here. Okay, yeah. It was basically v was given as 1 upon v was t over l, and what was basically t? Okay. T upon l. So we have to find 1 upon v here, unfortunately. 1 upon v, you can take basically any value, where this is just a ratio. So 1 upon v, so this is going to be t. You can take 0.23, so you can take this value 0.046, fine. 0.046, and then minus this with a was 374. Okay, and then try to find this. So what? This is not fair. This is not fair. This is a lot of mass, really. It should not be this much, There has to be something, something missing here that we haven't noticed yet. The student mass, the velocity changes. Okay, my god, wait a second. So I'm sorry, this is not the value of 1 upon v that we need to take. For 374, we got to basically check the mass of A at 374 from the graph actually. That's 350, 60, 70, and then we got to go. 374 will be somewhere in the middle. So we have to go up right here in the best fit line, and this would be basically the velocity. This is 51, 52, 53, 54, 0.0545, 0.0545. Wait, we have to add this. Okay,
So
now.
can you repeat what you did, please?
Yeah. I'll do that. Just let me just find this. I will explain it to you. 374 divided by 0.0545 minus 374. So this is going to be 2.5 times 10 raised to the power 1, 2, 3, 4, 5 grams. Okay, now let me tell you this. So basically, I made this equation. Basically, what I need is I need to find. No wait. This is not correct. Basically, what I did was, this is not correct actually. They have given me the value of 1 upon v as t upon l. Remember? You know? Okay. Now check this out. They say the glider has a mass m, so we already have the value of u and a. This was the equation. So basically what I did was, I wanted to find the mass from this equation, so I multiplied mass and a here. This was 2ua. I multiplied v times m plus v times a equals 2ua, and then basically I took v on the other side because I'm making m the subject of the equation. Okay, so this basically leaves me with minus va, and then when I divided v here, so it will be 2ua over v minus va over v. So basically this v and v cancels out, so ultimately I got 2ua over v equals to a. Is it clear, Kartika? So
So
I
should I have minus or equals
yeah
to?
minus. So basically we have we have the u value, we have the a value. That's what we found from the question above. And then we need 1 upon v. 1 upon v was given as t upon l. They have given t here that I was looking for. So this was t. And the length was basically the same, 5 centimeter, because that's given in the question. Where basically here it was given the length is always 5, right? So then we can find 1 upon v from here. So basically 0.5 divided by 5 is divided by 5 is 0.1. So this is the value I needed. And then minus a is 374. So when I put it in the equation, it's going to be 2 times 18.5 times 374 divided by 0.1 minus 374. So this is basically this answer, 1.38 times 10 raised to power 1, 2, 3, 5. Is it clear now? This is what you've done. Phew.
Yes.
Now the question is ended. Okay. So this basically is the whole thing.